Hello junior techies, and welcome to this video on the shapes of molecules. In this video we will look at what the different shapes that molecules can form are, and I will show you how you can go about determining the shape. But junior techies, I would like to emphasize that I will not be doing any big examples in this video. So if you would like to practice this, if you would like a few more examples, it is very important that you watch the practice videos after watching this theory video. Let's jump into it. So you now know about Lewis diagrams, but the problem with Lewis diagrams is that they're limited to 2 dimensions. Molecules are not 2-dimensional, they are 3-dimensional. So we make use of VEPR theory in order to determine these 3-dimensional shapes. VEPR theory stands for valence shell electron pair repulsion theory. Basically, what this theory explains is how the different types of electrons that you will find on your or in your molecule affect its structure, affect its shape. So we're going to make use of water just to ensure that you understand what I'm talking about. When we look at water, which is H2O, in between the oxygen and each hydrogen atom, we have a pair of electrons. This pair of electrons is called a bond pair of electrons. But you will also notice that on the oxygen atom, there are 2 other pairs of electrons. These electrons are called lone pair electrons, and the different pairs of electrons repel each other in different ways. So when we look at a bond pair exerting a force on another bond pair, like these 2 pairs of electrons, remember electrons are negatively charged, so they will repel each other. When we compare the bond pairs that repel each other versus a bond pair being repelled by a lone pair, we find that the bond pair and lone pair repel each other more. So these 2 electrons repel each other more than the bond pairs repel each other. When we look at a lone pair exerting a force of repulsion on another lone pair, there's even more repulsion, and that is why I've indicated this using the symbols you see on your screen. So based on this, we find that different molecules have different structures. When you look at water and carbon dioxide, you will notice that both of these molecules have 2 terminal atoms surrounding the one central atom. But if we look at the structure of water, you will notice that on the oxygen atom, there are 2 lone pairs. If you look at carbon dioxide, on the other hand, there are no lone pairs of electrons on carbon. Based on this, their shapes are different. Carbon dioxide is straight or has a linear shape, whereas water is bent. And the reason that it bends in the way that it does is because of the lone pairs that are on the central atom that are repelling each other and repelling the bond pairs of electrons. Now the steps that you can follow in order to use VEPR theory or in order to apply it are as follows. Very important, I will not be working through these steps. If you would like to work through the steps with me, you must watch the practice video. But these steps are as follows. Number 1, you need to draw the Lewis diagram of the molecule that you are dealing with. Number 2, you need to complete the general formula. In the general formula that you can see on the screen, the A represents the central atom, X represents the terminal atoms. The number of terminal atoms that you will find in the molecule is represented by the N, E stands for the lone pairs, and M is for the number of lone pairs that you will find specifically on the central atom. When you have completed the general formula, you can then use this general formula in order to determine the shape of the molecule. We can distinguish between ideal shapes and non-ideal shapes. Ideal shapes are those where there are no lone pairs on the central atom. These include the linear shape, which has the general formula AX2. We have trigonal planar, which is represented as AX3. There is tetrahedral, which is AX4. We have trigonal bipyramidal, which is AX5, and octahedral, which is AX6. Again, I would like to emphasize that the lone pairs that we are speaking about are those on the central atom. There may be lone pairs on the terminal atoms, that is fine, but the reason why we call these the ideal shapes, amongst other things, is because on the central atom there are no lone pairs. The other type of shapes that we will deal with are the non-ideal shapes, and you will find that these molecules do have lone pairs on the central atom. These include the angular shape. You can also refer to it as bent. This is AX2, and now notice the presence of the E, which stands for the terminal atoms. This is AX2 because in the example, or well, in any bent or angular molecule, you will find that on the central atom there are two lone pairs of electrons. The other non-ideal shape that you will work with is trigonal pyramidal. In these types of molecules, you will find the presence of one lone pair on the central atom, and the general formula is therefore AX3E. You could involve E1, but it is not necessary. We know that this E stands for only one lone pair of electrons. Ladies and gentlemen, we have reached the end of this video. I hope that you've learned from it everything that you came to learn, but remember that in order to retain all of the knowledge that you have learned, it is important that you practice. And since I did not go through any big or a lot of examples in this video, it is important for you to go ahead and watch the practice videos. I hope to see you in the practice videos and in the theory video that follows this one. Thank you very much for watching.